So we are going to start chapter 4 about the measures of variability. In the previous chapter, we learned measures of central location. The mean and the median are two major measures of central location. And so when you use one number to summarize the whole data, then the measure of central location is usually your choice. But when you have an additional, when you can use another number to summarize the data, then you need to complement the information that's not included in the measure of central location. So then, usually the choice is measure of central location and a measure of variability, right? So because this is the most important information that is missing from the measure of central location. Okay, so for example, let's think about two different groups and they have different histograms, like blue and red have definitely different distributions as you can see from these histograms, right? So then from these two histograms like this and like this, their difference is explained by the center. Blue has center here, red has their center here. So their difference between the means can explain the difference between these two groups. This is what the measure of central location does, right? So by comparing two averages, you can tell the difference. However, in this case, story is a little bit different because blue has this kind of distribution and red has this kind of distribution. The problem is the center is the same about this, about here, right? So if you just give two averages for each group, then you cannot tell the difference, right? They will be pretty much the same. So how can we, that means the average or the measure of central location has some missing information. So these two histograms are definitely different, but the averages are the same. Then you need something else to complement the average. And as you can see from this histogram example, what is missing is the spread, right? That means how much the distribution moves, right? Here, blue histogram is more flat and more wider, but red is more concentrated and higher in the middle. Okay, that's what we are going to study in this chapter. Okay. So let me briefly compare the difference between central location and variability. So the measures of central location capture where the observations are located. It's about just location. But it loses information about everything else. It only tells you about the center. But the lost information is usually how far observations are from the center. This is the key information that is missing. So we would like to use measures of variability to recover this information, right? So they complement each other by capturing different aspects. So simply speaking, the measures of central location give you the center, and the measures of variability give you the distance from the center. That's what we're going to do. Okay, so let me give you another example. So you think about two different cities, Honolulu and Phoenix, and that their weather, their climate are so different, right? Honolulu is like oceanic weather, but Phoenix is more like a desert. So then, guess, which city do you think have the higher average annual temperature? You don't need to know this, just as a brain teaser. The answer is Honolulu. Honolulu has slightly higher temperature than Phoenix, according to Wikipedia, several years ago. But what I wanted to tell you here is, as I said earlier, Honolulu is very much different from Phoenix, right? But their averages do not capture that difference, right? Honolulu has very like stable temperature around the year, but Phoenix has very hot summer and cold winter. So like not as cold as Albany, but you know. So these two difference is not capturing the true actual difference between these two cities. So that what's missing is here. To contrast these two weathers, a better way is to give you these numbers. So Honolulu, the coldest month, January, is only as low as 66 degrees. And in the hottest month, it's only 88 degrees Fahrenheit. But in Phoenix, the hottest month goes up as high as 106, but the coldest as low as like 45. So as I explained, it is not a matter of the average. It is about their variability, how much they move around the year. That's what we would like to capture. So, and similar idea can be applied to many other topics. Or like when we think about weather, then it is about the difference between the coldest and the hottest month. But if you apply that to income distribution, then the variability of income captures income inequality. And when you apply the variability to financial returns data, that is financial risk, right? Some certain like company returns like kind of stable returns, dividends, but other companies may have very fluctuating, like very risky dividends. That's the variability of returns. And if you apply the idea to manufacturing, then it is about precision. So you have to make a certain product in a certain size, but if something is too big or something is too small, that is a problem of variability, not about average. Okay. So like these are some examples, the reason why we have to study measures of variability. Okay. So then in this slide, in this chapter, we are going to study two different types of measures of variability. One is percentile based and the other is mean based. We learned those two different approaches in chapter 3. Mean is average and percentile includes the median as a special case. Percentile is about, literally percent relative standing. And if you use percentile, and then you get range and interquartile range. Remember, quartile is, I will explain that later again. We learned quartile in chapter 3. Mean, if you rely on the mean approach, then the variance and the standard deviation follows. So I believe you have heard about the variance and standard deviation before. Let me explain the percentile approach first, right? But actually the standard deviation and variance are more common measures in practice. But like because percentile approach is simpler, I will explain that first. So let me start with range. Range is pretty simple. It is the difference between maximum and minimum. So it captures how much the maximum variation in the data, right? So it's obvious, the greater the range is, the greater the variation in data. Like the maximum is higher, the minimum is lower. So that is the range. So for example, weather example is a nice example for this. So it compares the hottest temperature and the coldest temperature, right? So then within a year, month to month, the temperature moves as much as 21.6 degrees in Honolulu. Similarly, in Phoenix, the hottest month is as high as 106, and lowest is as low as 45. So in a year, month to month, the temperature changes as much as 50 degrees. So that is the range. It's so simple, right? It's very simple and intuitive, easy to interpret. You understand what I'm saying here. However, the problem is outliers, right? In the previous chapter, we also learned the problem of outliers, right? Range is now very sensitive to outliers. Let me show you the reason. So think about this histogram. I simulated just random numbers, and what we are going to calculate for range is the minimum and the maximum. Okay, minimum and the maximum. So that means no matter how many observations you have, we are going to use only 2 observations to calculate the range, right? Only 2 observations. That also they are the extreme observations. That is the problem of the range. So now then, so from the same data, I by mistake entered a number that is too small, right? So say I wanted to enter say like minus 1.3, but by mistake I entered minus 3, for example. Then I got an outlier, so suddenly the range becomes 4.79. The range was 3.67. So just by an error, the range is changing a lot, right? So like by another error, you may make like we could get a even smaller outlier or even greater outlier. So that is the problem. As I said, the range depends on the only 2 observations, the smallest and the largest observation, and by mistake, by an error, if one of those 2 extreme values are affected, then you are in trouble. The range will be very sensitive to those errors. That is the problem, right? So then, how can you fix that? To fix this problem, we are going to modify the range to interquartile range, right? To understand the interquartile range, let me first review what we learned in chapter 3. So quartile is when you have a distribution, we divide the distribution into 4 pieces, 4 equal probabilities. And then we call the first cutoff as first quartile, and the second one as second quartile, and the third one is third quartile, right? So of course the second quartile equals median because it's the point that divides the distribution into half and half. So anyhow, so first quartile is the same term as 25 percentile, and third quartile is 75 percentile. It's pretty simple. So then our idea is, okay, the problem with the range was we are using 2 extreme values, so they are very vulnerable to outliers, right? Those 2 extreme values might be outliers. So then, okay, let's remove the outliers. I'm going to remove 2 large numbers as much as 25%. I will delete this much. Top 25%, like, so then all the outliers will be deleted, top 25%. And also I will delete the other side. Lower 25% will be deleted. I will delete this, right? So because also the lower side outliers would be deleted within this 25%. Okay, so then we have now middle 50%, and we use range using these middle 50% observations. That is the idea. We delete bottom 25% and top 25% and calculate the range of the remaining middle 50%. That's the idea. Okay. Then all the intuition for the range like applies to the interquartile range too. The larger the interquartile range, then the more variation the data have, right? And also it is very robust against outliers, right? As you can see, like extremely small numbers and extremely large numbers will be automatically deleted. So the effect of outliers will be very minimal. Here is an example, right? Like we have data like that, and here is the outlier, but it will be deleted. We don't care. So even if it was here or there or here, it will be deleted. So it's not a problem. And also similarly, if there was outlier like here or here, so it will be anyhow deleted. So they don't affect the first quartile and the third quartile, and this difference is the interquartile range. As you can see, deleting the extreme values, we calculate interquartile range. Of course, the scale is smaller than the range, but it's robust against outliers. Okay, I'm going to continue the variance and standard deviation in the next video.